Hey guys, tonight we are diving beneath one of the most isolated places on Earth, where the Antarctic ice shelf meets the ocean in a world that exists in complete darkness, a place so remote and alien that you definitely wouldn't survive this without some serious protection. Picture yourself suited up in the most advanced diving gear imaginable, your headlamp cutting through water so cold it would freeze your blood in seconds, descending through a crack in ice that has been frozen solid for thousands of years. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. I'm curious too. Drop a comment letting me know where you're listening from and what time it is there. It's always fascinating to know this mystery is unfolding simultaneously around the globe. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You find yourself at the edge of the Ross Ice Shelf, one of Antarctica's largest floating ice formations, where scientists have recently discovered something extraordinary hidden beneath the frozen surface. The ice above you stretches for hundreds of miles, a ceiling of frozen water that blocks out every trace of sunlight, creating a realm that exists in perpetual midnight. Your breathing apparatus hums softly as you adjust to the strange sensation of floating in water that hovers just above freezing, so clear you can see for surprising distances, despite the complete absence of natural light. The crack you descended through was created by researchers who drilled nearly half a mile down through solid ice, following temperature readings that suggested something unusual was happening in the water below. As you drift deeper, you notice the walls of ice surrounding you are not the pristine white you might expect. Instead, they show layers of history, bands of different colors that tell the story of countless winters, each line representing years of snowfall compressed into this frozen archive. The water around you moves with currents that seem impossible, flowing in directions that defy what you know about how water should behave under ice. These currents carry with them a strange warmth, not enough to melt the ice above, but sufficient to maintain liquid water in this hidden chamber. You realize you are witnessing something that challenges our basic understanding of Antarctic ecosystems, a place where life persists in conditions that should be completely hostile to any living thing. Marine biologists first stumbled upon evidence of these hidden worlds when they noticed unusual chemical signatures in ice core samples, traces of organic compounds that suggested biological activity was occurring somewhere beneath the frozen surface. The discovery sparked years of debate among researchers who struggled to explain how complex ecosystems could exist in such extreme isolation. Some argued that the findings were contamination from surface activities, while others insisted they had discovered proof of life forms that had evolved in complete separation from the rest of the planet's biosphere. Ancient legends from Antarctic explorers occasionally mentioned sounds coming from beneath the ice, low rumbling noises that seemed to emanate from deep below the frozen surface. These reports were typically dismissed as ice settling or thermal expansion, but modern acoustic equipment has confirmed that something beneath the ice shelves does produce regular sound patterns, frequencies that suggest biological rather than purely geological origins. Researchers still argue that these underwater chambers might represent some of the most pristine ecosystems on Earth, places where life has continued uninterrupted for thousands of years, while the surface world above went through dramatic climate changes. The isolation of these environments means that any life forms here have been evolving independently, potentially developing characteristics found nowhere else on the planet. As you continue your descent, You notice the ice formations around you become more complex, creating cathedral-like spaces with arches and pillars that stretch both above and below your position. The acoustic properties of these spaces are remarkable. Every sound you make echoes in ways that seem to amplify and distort, creating an otherworldly symphony of reverberations that bounce off the ice walls in patterns that feel almost musical. Your depth gauge shows you have traveled much deeper than expected, the hidden chamber extending far below the original estimates. The pressure around you increases gradually, but the water remains liquid, maintained by geothermal activity that seeps up from the ocean floor below. This delicate balance of temperature and pressure creates conditions that exist nowhere else on Earth, a unique environment that serves as a bridge between the frozen surface world and the deep ocean systems that circulate around Antarctica. The darkness around you is so complete that your artificial lights create pools of visibility that fade quickly into black void. Yet somehow the space feels vast, as if you are floating in an underwater cathedral whose dimensions extend far beyond what your lights can reveal. You drift deeper into this twilight zone beneath the ice, where your eyes begin to adjust to something extraordinary that defies the complete darkness you expected to find. Tiny points of light begin to appear around you, not from any external source, but from the creatures themselves, bioluminescent organisms that have turned this frozen underworld into their own private constellation. These living lights pulse and flicker in patterns that seem almost deliberate, as if the darkness itself has learned to communicate through brief flashes of blue and green illumination. The first creatures you encounter are unlike anything in the surface oceans above. Translucent jellies that drift past you with ethereal grace, their bell-shaped bodies generating soft pulses of light that ripple outward like underwater fireworks. Each pulse serves multiple purposes. Some flashes appear to be hunting signals, brief strobes designed to stun or confuse prey, while others seem to be communication attempts, complex patterns that other jellies respond to with their own light sequences. Marine biologists studying these bioluminescent displays have discovered that the light-producing organs in these creatures are far more sophisticated than their surface-dwelling relatives. The luciferin compounds they use to generate light have evolved to work efficiently in near-freezing temperatures, a biochemical adaptation that required millions of years of isolation to develop. The wavelengths of light these organisms produce are specifically tuned to travel maximum distances through the dense cold water, creating an underwater internet of biological signals. You notice that different species seem to operate on different light frequencies. Some creatures flash in rapid bursts, while others maintain steady glows for extended periods. The patterns remind you of a city at night, viewed from an airplane, clusters of activity connected by streams of moving lights. Except this city exists in 3 dimensions, with residents that can move freely up and down through the water column as well as horizontally through their liquid neighborhoods. Researchers still argue that these bioluminescent communications might represent one of the most complex signaling systems in the natural world, potentially rivaling the sophistication of dolphin echolocation or bird migration patterns. Some scientists believe the light displays serve as a form of underwater language, while others insist they are purely functional hunting and mating behaviors that only appear complex to human observers. The myths surrounding lights beneath polar ice date back to indigenous peoples who described strange glows that sometimes appeared under frozen lakes and coastal ice formations. These stories often included descriptions of spirits or supernatural beings that lived in the underwater darkness. beings that communicated through colored lights that danced beneath the ice like aurora displays reflected in reverse. As you move through this living light show, you begin to notice larger shapes moving in the periphery of your vision, creatures that generate more sustained illumination and seem to be observing your presence with what appears to be curiosity rather than fear. These larger bioluminescent organisms pulse with patterns that change when you move, almost as if they are trying to establish some form of communication with your artificial lights. One particularly fascinating discovery is how these creatures have adapted their light production to the unique acoustic properties of their environment. Remember the cathedral-like echoes from the ice formations you encountered earlier. It turns out the bioluminescent flashes often coincide with sound production, creating multimedia displays that combine light and acoustic signals in ways that maximize communication range through the complex underwater topography. The energy efficiency of these light displays is remarkable. Each flash uses minimal metabolic resources while producing maximum visual impact. This efficiency is crucial in an environment where food sources are extremely limited and every calorie must be carefully conserved. The creatures have essentially turned their bodies into living LED systems, producing bright illumination with almost no waste heat, a biological technology that human engineers are only beginning to understand and replicate. You realize that you are witnessing an ecosystem that has been perfecting its survival strategies in isolation for millennia, developing solutions to the challenges of life in permanent darkness that are both elegant and alien to surface world biology. The bioluminescent displays around you represent not just pretty lights, but sophisticated survival technologies that allow complex communities to thrive in conditions that would quickly kill most surface organisms. The deeper you drift, the more varied the light displays become, from simple on-off flashing to complex color-changing sequences that sweep across the bodies of larger organisms like organic neon signs. Some creatures seem to coordinate their displays with neighbors, creating synchronized light shows that span dozens of individuals, turning sections of the underwater space into temporary theaters of biological illumination that appear and disappear like underwater thunderstorms made of living lightning. You continue your exploration through this bioluminescent wonderland until something catches your attention near the ice ceiling above. Structures that at first appear to be natural formations, but reveal themselves to be something far more extraordinary upon closer inspection. Massive colonies of amphipods, tiny shrimp-like creatures no larger than your thumbnail, have constructed what can only be described as cities suspended from the underside of the ice shelf, intricate three-dimensional communities that stretch across acres of frozen ceiling in patterns that would make human urban planners envious. These amphipod metropolises are built from materials the creatures have gathered and secreted, creating tube-like structures that branch and interconnect like organic subway systems. Each tube provides shelter for dozens of individuals, while connecting to larger communal spaces where hundreds of amphipods gather in what appears to be coordinated social behavior. The architecture defies everything scientists thought they knew about the organizational capabilities of such small crustaceans, displaying engineering principles that suggest collective intelligence operating on a scale never before documented in marine environments. The construction process itself is mesmerizing to observe. You watch as groups of amphipods work together to extend their tubular highways, some individuals gathering building materials, while others focus on the actual construction, passing materials along in bucket brigade fashion with efficiency that would impress any construction foreman. The materials they use include organic compounds filtered from the water, minerals scraped from the ice above, and secretions from their own bodies that harden into a cement-like substance in the cold water. Marine architects studying these structures have discovered that the amphipod cities incorporate sophisticated ventilation systems that ensure fresh water circulation throughout the colony, preventing the buildup of waste products that could poison the community. The tunnels are designed with specific diameter ratios that maximize water flow while minimizing energy expenditure for the residents moving through them. Some passages appear to be designated as highways for rapid transit, while others function as nurseries, where young amphipods develop in protected chambers. Researchers still argue that these colonies represent either the most advanced invertebrate social organization ever discovered, or simply the result of basic behavioral programming that creates the illusion of intelligent design. The debate centers around observations of apparent decision-making processes within the colonies, instances where the entire community seems to coordinate responses to environmental changes in ways that suggest communication and planning abilities that exceed current understanding of crustacean cognition. Ancient folklore from polar regions includes stories of ice spirits that built elaborate homes beneath frozen surfaces, invisible cities that existed in the space between water and ice, where supernatural beings carried out their daily activities, hidden from human observation. These legends often described the sound of construction activity coming from beneath the ice during quiet winter nights, rhythmic tapping and scraping that early explorers attributed to supernatural causes rather than biological ones. The scale of these amphipod settlements is staggering. Some colonies extend for several hundred yards along the ice ceiling, representing the combined labor of millions of individual creatures working across multiple generations. The oldest sections of established cities show signs of renovation and expansion, suggesting that these communities persist long enough to require infrastructure updates and population-driven growth management, concepts typically associated with human settlements rather than invertebrate colonies. You notice that the bioluminescent creatures you observed earlier seem to interact regularly with these amphipod cities. Some of the light-producing organisms appear to have established symbiotic relationships with the city dwellers, providing illumination for the colony tunnels in exchange for shelter or food-sharing arrangements. This creates neighborhoods within the cities where the tube structures glow softly from within, organic street lights that make navigation easier for residents, while creating an otherworldly beauty that transforms the utilitarian architecture into something resembling an underwater fairy tale. The traffic patterns within these cities are surprisingly organized. You can observe rush hour-like phenomena where large numbers of amphipods move through the main thoroughfares in coordinated waves, typically following the natural rhythm of feeding cycles that correspond to nutrient availability in the surrounding water. During peak activity periods, the cities buzz with movement that creates subtle vibrations through the water, an urban soundtrack of millions of tiny bodies moving through their aquatic neighborhoods. The most remarkable aspect of these settlements is their integration with the ice shelf ecosystem. The amphipods have learned to work with the natural expansion and contraction of the ice above, building their structures with flexible joints that accommodate thermal movement without compromising structural integrity. When sections of ice shift or crack, the colonies rapidly mobilize repair crews that can reconstruct damaged areas within hours, demonstrating a level of community resilience that human cities struggle to achieve. Some of the larger colony complexes include what appear to be specialized districts, areas designated for specific activities like food processing, waste management, or reproduction, suggesting a level of urban planning that rivals human cities in its sophistication and attention to functional efficiency. You pause your exploration to focus on something that has been present throughout your journey, but only now demands your full attention. The ice itself is singing. The massive walls and ceiling of frozen water that surround you produce haunting acoustic phenomena that range from deep bass notes that vibrate through your body to high-pitched crystalline chimes that seem to emanate from the molecular structure of the ice itself. These sounds are not random noise, but appear to follow patterns and rhythms that suggest the glacier above is participating in some form of massive, slow-motion symphony. The acoustic properties of this underwater ice cathedral create natural amplification chambers that take the slightest sound and transform it into complex harmonics that bounce between the frozen surfaces in ways that seem almost intentionally musical. When pressure changes occur deep within the ice shelf, caused by temperature fluctuations or gravitational stress, the resulting sounds travel through the ice structure like notes played on an instrument larger than any human construction, creating music that has been performing for audiences of marine life for thousands of years. Glaciologists studying these acoustic phenomena have discovered that the ice produces different frequencies depending on its age, density, and internal structure. Younger ice near the surface creates higher-pitched sounds when it shifts or cracks, while ancient ice deep within the shelf generates profound bass notes that can travel for miles through both the ice and the surrounding water. The combination creates a natural orchestra where different sections of the glacier contribute their own instrumental voices to an ongoing composition that changes with seasons, weather patterns, and long-term climate cycles. You can feel the larger sounds as much as hear them, deep reverberations that pass through the water and into your body, creating a sensation similar to standing too close to powerful speakers at a concert, except these vibrations carry information about the massive geological processes occurring in the ice above you. Some frequencies seem to trigger responses from the marine life around you. The amphipod cities you observed earlier show increased activity when certain notes resonate through their neighborhoods, while the bioluminescent creatures often synchronize their light displays with particular acoustic patterns. Researchers still argue that these ice songs might serve as communication mechanisms for the ecosystem itself, natural timing signals that help coordinate biological processes across the isolated underwater environment. Some scientists propose that marine organisms have learned to interpret the ice music as environmental information, using the acoustic patterns to predict changes in temperature, pressure, or nutrient availability that affect their survival strategies. The folklore of Antarctic explorers includes numerous references to singing ice and ghostly music that seem to come from within the glaciers themselves. Early expedition reports describe nights when the entire ice shelf would produce sounds resembling whale songs, organ music, or human voices calling from within the frozen depths. These accounts were typically attributed to psychological effects of isolation and extreme cold, but modern acoustic monitoring has confirmed that glaciers do indeed produce complex sound patterns that can resemble musical compositions or vocal communications. The physics behind these ice songs involves thermal expansion and contraction cycles that occur within the glacier structure as different layers of ice respond to temperature changes at different rates. The resulting stress creates fractures and pressure releases that generate sound waves. The specific frequencies depend on factors like ice density, air bubble content, and the presence of liquid water within the ice matrix, creating a natural synthesizer that produces an ever-changing soundtrack for the underwater world below. Remember the bioluminescent light shows you witnessed earlier. You now realize that many of those displays were actually synchronized with the ice music, creating multimedia performances where living creatures provide the visual effects while the glacier itself serves as the audio component. This coordination suggests that the entire ecosystem has evolved to work together as an integrated sensory experience, where sound and light combine to facilitate communication and environmental awareness among the various species sharing this isolated world. The most impressive acoustic events occur when large sections of the ice shelf adjust to tidal forces or temperature changes, creating sounds that resemble massive pipe organs playing compositions that can last for hours. During these performances, the entire underwater chamber becomes a resonance cavity where every surface contributes to the acoustic complexity, turning your underwater cathedral into a concert hall where the architecture itself is both the instrument and the performer. Some of the ice songs include frequencies that are below the range of human hearing, infrasonic vibrations that travel enormous distances through both ice and water, potentially serving as long-range communication signals that connect isolated underwater ecosystems across hundreds of miles of Antarctic ice shelf, creating a network of acoustic connections that link separated communities of marine life in ways that scientists are only beginning to understand. You descend further from the amphipod cities and the singing ice walls toward what initially appears to be the barren seafloor. But as your lights penetrate the darkness below, you discover something that challenges every assumption about life in sunless environments. Vast gardens spread across the bottom of this underwater chamber, not the familiar green plants of the surface world, but intricate bacterial mats and chemosynthetic organisms that have created their own version of Eden in complete darkness, using chemical energy instead of sunlight to fuel complex ecosystems that rival tropical rainforests in their biodiversity and beauty. These bacterial gardens form colorful carpets that stretch in every direction, creating patterns that look like abstract art painted by microbial artists working with pigments that range from deep purples and bright oranges to electric blues and luminescent greens. Each color represents different bacterial communities that have specialized in processing specific chemical compounds, creating a living chemistry set that transforms the harsh conditions of this isolated environment into resources that support increasingly complex food webs. The primary energy source for these gardens comes from chemical compounds that seep up from the sea floor through hydrothermal processes, hydrogen sulfide and methane that would be toxic to most surface life forms, but serve as the foundation of prosperity for these chemosynthetic communities. The bacteria harvest energy from these chemicals through processes that are fundamentally different from photosynthesis, creating organic compounds that feed not only themselves but entire hierarchies of larger organisms that depend on the bacterial gardens for survival. Marine biochemists studying these systems have discovered enzyme pathways that are completely unknown in surface ecosystems, chemical processes that operate efficiently at near freezing temperatures and produce no waste products that would contaminate the pristine environment. Some of the bacterial species appear to be living fossils, organisms that have remained virtually unchanged for millions of years, while continuing to perfect their chemical manufacturing processes in the stable conditions provided by their ice-covered isolation. You notice that the bacterial mats are not static formations, but dynamic communities that respond to environmental changes with coordinated behavior that resembles plant growth patterns, except these movements occur over hours rather than days or seasons. Areas of the garden expand and contract based on chemical gradients in the water, creating waves of color that flow across the sea floor like time-lapse footage of blooming flowers, except these blooms are made of billions of microscopic organisms working together to optimize their chemical harvesting efficiency. Researchers still argue that these bacterial gardens might represent the closest analogues to early Earth ecosystems that existed before photosynthesis evolved, providing living examples of how life functioned during the planet's first billion years, when the atmosphere contained no oxygen and all biological energy came from chemical processes rather than solar radiation. Studying these communities could provide insights into how life might exist on other planets, where sunlight is not available, but chemical energy sources are present. The mythology surrounding gardens in the dark places appears in cultures worldwide. Stories of underground paradises where magical plants grow without sunlight, sustained by supernatural forces that transform barren landscapes into places of abundance and beauty. These legends often describe the gardens as places of healing, where rare medicines could be found, plants with properties that existed nowhere in the surface world, descriptions that seem remarkably similar to the unique biochemical compounds that modern scientists are discovering in chemosynthetic bacterial communities. The complexity of these bacterial gardens extends beyond simple mats on the seafloor. Three-dimensional structures rise from the bottom like underwater trees, bacterial formations that create vertical habitats where different communities occupy different levels based on their chemical preferences and processing capabilities. Some of these bacterial towers reach several meters in height, creating underwater forests that provide shelter and feeding opportunities for the mobile organisms that visit the gardens like underwater grazing animals. Remember the ice songs you experienced earlier. The bacterial communities appear to respond to certain acoustic frequencies with changes in their metabolic activity, suggesting that the entire ecosystem uses the glacier's musical output as environmental information that helps coordinate biological processes across different habitat zones. When particular notes resonate through the water, sections of the bacterial gardens show increased activity, almost as if the music serves as a dinner bell that signals optimal conditions for chemical processing. The nutrient cycling within these gardens is remarkably efficient. Waste products from one bacterial community become food sources for neighboring communities, creating closed-loop systems that waste virtually nothing while producing surplus organic compounds that support the larger ecosystem. This efficiency allows the gardens to thrive despite the extremely limited external inputs available in their isolated environment, demonstrating biological resource management that could teach human societies valuable lessons about sustainability. Some areas of the gardens seem to pulse with their own rhythms, coordinated changes in color and activity that sweep across large sections of the bacterial mats like biological waves, creating hypnotic patterns that combine with the bioluminescent displays of visiting organisms to turn the sea floor into a living light, show that rivals any human-created visual entertainment. You pause in your exploration of the bacterial gardens to sample the water around you, only to discover that you are swimming through liquid history, ancient water that has been trapped beneath this ice shelf for millennia, carrying chemical signatures and isotopic ratios that tell the story of Earth's climate stretching back thousands of years. This water is older than human civilization, older than the pyramids, older than agriculture, a liquid time capsule that has preserved information about prehistoric ocean conditions in its molecular structure like a chemical library written in dissolved minerals and trace elements. The analysis of this ancient water reveals composition patterns that are dramatically different from modern ocean water, containing concentrations of certain isotopes that reflect atmospheric conditions from periods when the global climate was radically different from today. Scientists studying water samples from similar isolated chambers have discovered evidence of ice ages, warming periods, and atmospheric events that occurred long before human record-keeping began. Information that has been preserved in the chemical makeup of water that has remained undisturbed for millennia. Each molecule of this ancient water carries information about the global ocean system that existed when it was first trapped beneath the ice, trace elements that reveal details about ocean temperature, salinity patterns, and biological productivity from prehistoric periods. The water serves as a chemical fossil, preserving environmental data with precision that rivals ice core samples, while providing additional information about ocean chemistry that cannot be obtained from frozen archives alone. You realize that as you move through this underwater chamber, you are essentially swimming through a three-dimensional timeline where different depths and locations contain water from different historical periods, creating gradients of time that allow scientists to study climate transitions and environmental changes with unprecedented resolution. Some areas contain water that was trapped relatively recently in geological terms, perhaps only a few hundred years ago, while other sections preserve water that has remained isolated since the last major ice age thousands of years ago. Marine geochemists have discovered that the chemical stratification of this ancient water creates distinct layers with different properties, similar to how a fine wine develops complex flavors through aging, except these layers contain information about global environmental conditions rather than grape harvests. The oldest water shows chemical signatures of ocean conditions that existed when global sea levels were dramatically different and entire continents were covered by ice sheets that no longer exist. Researchers still argue that these ancient water reserves might contain microorganisms that have been isolated from evolutionary pressure for thousands of years, potentially preserving genetic lineages that represent snapshots of microbial communities from prehistoric periods. Some scientists believe that studying these ancient microbial populations could provide insights into how life responds to major climate transitions, while others argue that the extreme isolation makes it impossible for complex biological communities to persist across such extended time frames. The legends of many coastal cultures include stories about waters with magical properties, pools or springs that contained the wisdom of ages, and could reveal the past to those who knew how to interpret their signs. These mythological waters were often described as being found in hidden places beneath ice or stone, locations where time moved differently, and the boundary between past and present became fluid. Descriptions that echo the actual properties of these ancient water masses preserved beneath Antarctic ice shelves. The temperature variations within this ancient water create subtle currents that flow in patterns determined by density differences that developed over centuries. Currents so slow and stable that they serve as liquid conveyor belts that have been operating continuously since before human civilization began. These currents carry dissolved nutrients and chemical information throughout the underwater chamber, distributing resources that support the bacterial gardens you observed earlier, while maintaining chemical gradients that have remained stable for extraordinary periods. Remember the bioluminescent creatures and their sophisticated light displays. Many of these organisms show adaptations that suggest their ancestors have been living in this specific water chemistry for thousands of generations, evolving specialized biochemical pathways that work optimally with the unique chemical conditions preserved in this ancient water. Their light-producing organs use chemical compounds that are rare in modern oceans, but were common in prehistoric marine environments, suggesting that these creatures are living representatives of ancient oceanic ecosystems. The pH levels and mineral content of different water layers create microenvironments within the large chamber. Some areas favor organisms adapted to more acidic conditions, while others support life forms that require higher concentrations of specific trace elements. This chemical diversity within the ancient water mass creates habitat niches that allow for remarkable biodiversity despite the isolated and extreme conditions of the overall environment. The salinity patterns in this ancient water reveal information about global ice sheet dynamics from past climate periods. Areas with higher salt concentrations indicate periods when more fresh water was locked up in continental ice sheets, while lower salinity zones correspond to warmer periods when glacial melting diluted ocean salinity worldwide, creating a liquid record of ice age cycles that extends far beyond what can be determined from conventional geological evidence. You drift away from the ancient waters toward a phenomenon that initially defies explanation: massive structures that sway in the currents like underwater trees, but reveal themselves to be something far stranger upon closer inspection. These are not plants in any conventional sense, but enormous colonial organisms that have grown into forest-like formations, reaching heights that span from the bacterial gardens on the sea floor all the way up toward the amphipod cities suspended from the ice ceiling above, creating vertical highways that connect all the different habitat zones of this underwater world. Each towering structure consists of thousands of individual organisms that have joined together to form a single living entity, similar to coral reefs, but adapted for life in the near-freezing darkness rather than tropical sunlight. The organisms that make up these living towers are translucent and elongated, creating flexible stems that bend and flow with the water currents while maintaining their overall vertical orientation, like kelp forests made of glass that pulse with their own internal rhythms. The swaying motion of these colonial forests creates currents that would be impossible in their absence. The massive structures act as underwater wind turbines that convert the subtle thermal currents in the ancient water into more dramatic flow patterns that distribute nutrients and oxygen throughout the chamber. This current generation appears to be intentional rather than accidental, suggesting that the colonial organisms have evolved to serve as the circulation system for the entire underwater ecosystem. Marine biologists studying similar colonial organisms in other extreme environments have discovered that the individual members of these colonies can communicate through chemical signals and electrical impulses, allowing the entire structure to coordinate responses to environmental changes, as if it were a single enormous organism with distributed intelligence. When one section of the colony detects favorable conditions, it can signal other sections to orient themselves toward nutrient sources or optimal current flows. You observe that different sections of these living towers show specialized functions. Some areas appear to be dedicated to nutrient absorption and processing, while other sections focus on reproduction or waste management. The colonial organisms have essentially created living skyscrapers where different floors serve different purposes. But unlike human buildings, these structures can reshape themselves in response to changing conditions, growing new sections where they are needed most, while allowing underutilized areas to be reabsorbed and recycled. Researchers still argue that these colonial forests might represent the largest single organisms on Earth, individual colonies that could potentially weigh more than blue whales, while extending through hundreds of feet of vertical water space. The debate centers around whether the colonial organisms maintain true individual identity or have merged so completely that they should be considered as single massive life forms that happen to be made up of billions of formerly separate creatures. The folklore of many seafaring cultures includes descriptions of underwater forests that moved with minds of their own, living trees beneath the waves that could trap sailors or guide them to safety depending on the traveler's intentions and respect for the ocean's mysteries. These stories often described the underwater forests as guardians of hidden treasures or secret knowledge, places where the boundary between plant and animal, between individual and community, became meaningless. The reproductive strategies of these colonial forests are particularly fascinating. During certain periods, the entire structure coordinates a synchronized release of reproductive cells that creates underwater blizzards of genetic material, transforming the clear water into clouds of potential new life that drift through the currents until they find suitable locations to establish new colonies. These reproductive events appear to be timed with the acoustic patterns from the singing ice above, suggesting that the glacier's music serves as a reproductive calendar for the colonial organisms. Remember the bacterial gardens that carpet the sea floor below. The colonial forests serve as living bridges that transport nutrients and chemical signals between the bottom-dwelling bacterial communities and the mobile organisms that inhabit the middle and upper water zones. The towers act as biological elevators, where nutrients processed by the bacteria can be carried upward to feed organisms that live closer to the ice ceiling, while waste products from the upper zones can be transported down to the bacterial gardens, where they serve as raw materials for continued chemical processing. The structural engineering of these living towers is remarkable. The colonial organisms have developed internal support systems that allow them to maintain their height and flexibility simultaneously, using fluid-filled chambers that can be pressurized or depressurized to adjust the rigidity of different sections as needed. During periods of strong currents, the towers become more flexible to avoid damage, while during calm periods they can stiffen their structure to maximize their height and reach toward optimal feeding zones. Some of the larger colonial forests show evidence of great age, with sections that appear to have been growing continuously for centuries, creating living historical records of environmental conditions that extend back through multiple generations of the other organisms that share this underwater world. The growth patterns in these ancient colonies reveal information about past climate events, periods of abundant or scarce nutrients, and environmental stresses that have shaped the ecosystem over extended timescales. You are drifting through the swaying colonial forests when movement from above catches your attention. Shadows passing across the ice ceiling that seem too large and purposeful to belong to the resident marine life you have been observing. These are visitors from the surface world, seals and whales that have discovered access points to this hidden realm and occasionally breach the boundary between the frozen surface and the liquid world below, creating temporary bridges between two completely different ecosystems that exist mere meters apart, yet remain largely isolated from each other. The arrival of a Weddell seal through one of the ice cracks transforms the entire underwater chamber, its sleek form cutting through the ancient waters with powerful strokes that create pressure waves affecting every level of the ecosystem. The seal's presence triggers responses throughout the community. The bioluminescent creatures increase their light displays as if announcing the arrival of a distinguished guest, while the amphipod cities show bursts of activity as residents emerge from the tunnels to observe the massive visitor navigating through their vertical neighborhoods. These surface visitors bring with them traces of the outside world, oxygen-rich water from their breathing, organic compounds from their recent surface meals, and most importantly, genetic material that provides occasional infusions of diversity into the otherwise isolated gene pools of the permanent residents. When seals dive to hunt in these chambers, they inadvertently serve as biological messengers, carrying information and resources between the hidden world below and the vast Antarctic ecosystem above. Marine mammalogists have discovered that some seals appear to make regular visits to specific under-ice chambers, suggesting they have learned to navigate the complex network of cracks and passages that connect these hidden worlds to the surface ocean. These regular visitors seem to have established relationships with the permanent residents, diving patterns that avoid disturbing critical habitats while taking advantage of feeding opportunities that exist nowhere else in the Antarctic marine environment. You watch as the seal investigates the colonial forests, its echolocation calls creating acoustic patterns that blend with the singing of the ice walls, adding new frequencies to the underwater symphony that has been playing continuously for millennia. The seal's sonar appears to be more sophisticated when used in these chambers, taking advantage of the complex acoustic properties created by the ice formations and living structures to build detailed three-dimensional maps of this hidden world. Researchers still argue that these occasional surface visitors might be essential for the long-term survival of the isolated ecosystems, providing genetic diversity and environmental information that prevents the communities from becoming too specialized for their extreme conditions. Some scientists believe the visitors serve as evolutionary pressure valves, introducing new genetic material that keeps the isolated populations viable over extended periods, while others argue that the ecosystems have become so specialized that outside influences might actually be disruptive rather than beneficial. The indigenous peoples of Antarctica, primarily the research communities that have lived there for extended periods have developed their own folklore about animals that travel between worlds, creatures that serve as messengers between the known surface world and mysterious realms that exist beneath the ice. These modern myths often describe encounters with marine mammals that seem unusually intelligent or aware, as if they carry knowledge from places that humans cannot easily access. The hunting behavior of visiting seals in these chambers is remarkably different from their surface feeding patterns. They appear to have learned specialized techniques that take advantage of the unique conditions and prey availability in the isolated environment. Some seals have been observed cooperating with the bioluminescent creatures, using the living lights as hunting aids in ways that suggest a level of interspecies communication that exceeds normal predator-prey relationships. Remember the ancient water that carries chemical information from prehistoric periods? The surface visitors inadvertently collect samples of this historical water in their tissues and transport it back to the surface world when they return to breathe. This creates a slow but continuous exchange of chemical information between the isolated chambers and the modern ocean system, allowing scientists to study these hidden environments indirectly through analysis of visiting marine mammals. The impact of surface visitors extends beyond their immediate presence. Their movements through the water create mixing patterns that redistribute nutrients and chemical gradients throughout the chamber, stirring up sediments from the bacterial gardens and creating turbulence that benefits filter-feeding organisms throughout the water column. These mixing events appear to be timed with the visitors' breathing cycles, creating rhythmic pulses of environmental change that add another layer to the complex timing systems that coordinate ecosystem activities. When larger whales occasionally access these chambers through wider cracks or temporary openings in the ice, their presence creates dramatic changes throughout the entire system. The massive bodies of these visitors generate pressure waves that can be felt by organisms throughout the chamber, while their whale songs combine with the ice acoustics to create sound experiences that exist nowhere else on Earth. Underwater concerts where living musicians perform alongside geological instruments in venues that few humans will ever experience directly. You follow the path of the visiting seal as it navigates through the chamber using what appears to be an invisible highway system, and you begin to understand that this isolated underwater world is not truly isolated at all, but connected to the global ocean system through deep current highways that flow beneath the ice shelf, like underground rivers connecting distant continents. These mysterious circulation patterns create pathways that carry water, nutrients, and occasionally living organisms across vast distances, linking this hidden ecosystem to ocean systems thousands of miles away through networks that operate below the frozen surface of Antarctica. The deep currents that flow through this chamber follow patterns that were established millions of years ago when the Antarctic ice sheet first formed, creating circulation systems that have remained remarkably stable even as surface climate conditions have changed dramatically over geological time. These ancient current pathways serve as the circulatory system for the entire under-ice ecosystem, bringing fresh nutrients from distant ocean regions while carrying away waste products that would otherwise accumulate to toxic levels in the isolated environment. You can feel the power of these deep currents as they flow past you, water masses that carry the energy of global ocean circulation systems compressed into relatively narrow channels beneath the ice shelf. The currents move with surprising speed and consistency, creating underwater rivers that maintain their distinct temperature and chemical properties even as they flow through the chamber, bringing traces of tropical waters, Arctic conditions, and mid-ocean chemical signatures to this seemingly isolated Antarctic environment. Oceanographers studying these deep circulation patterns have discovered that they operate on multiple timescales simultaneously. Some currents respond to daily tidal cycles and seasonal changes, while others follow patterns that take decades or centuries to complete full circulation loops. The longest cycle currents appear to be connected to global climate oscillations, bringing water that began its journey in distant ocean basins during different climate periods, creating a living library of global ocean conditions that flows continuously through these hidden chambers. The biological implications of these current highways are extraordinary. They serve as migration routes for organisms that would otherwise be trapped in isolated environments, allowing genetic exchange between populations separated by thousands of miles of ice and ocean. Some organisms appear to ride these currents intentionally, timing their reproductive cycles to coincide with favorable current conditions that will transport their offspring to suitable habitats in distant under-ice ecosystems. Researchers still argue that these deep current systems might be more important to global ocean circulation than previously understood, potentially serving as critical pathways that help maintain the stability of worldwide climate patterns. Some scientists believe that disruption of these under-ice circulation systems could have cascading effects on global ocean currents, while others argue that the systems are too small and isolated to significantly influence planetary-scale ocean dynamics. The mythology of many maritime cultures includes stories of underwater rivers that connected distant seas, hidden pathways that allowed supernatural beings or legendary creatures to travel between different ocean realms without surfacing into the human world. These stories often described the underwater rivers as shortcuts through space and time, where a journey that should take months could be completed in days by those who knew how to navigate the secret currents beneath the waves. Remember the colonial forests that sway in coordinated patterns throughout the chamber. Their movements are actually responses to the subtle variations in these deep current flows. The living structures serve as current meters that respond to changes in flow direction and velocity with movements that can be read like a biological barometer. The forests have essentially become part of the circulation system. Their swaying motions help to mix and distribute the different water masses as they flow through the chamber. The chemical signatures carried by these deep currents provide information about ocean conditions throughout the global system. Water that flows through this chamber today might have originated in the Pacific Ocean years ago, carrying dissolved minerals and trace elements that reflect environmental conditions in regions thousands of miles away. This creates a situation where studying the water in this isolated chamber provides insights into global ocean health and climate patterns that extend far beyond Antarctica. The temperature variations within these current highways create thermal landscapes that different organisms use for navigation and habitat selection. Some species prefer to remain in the warmer core of certain currents, while others thrive in the cooler boundary zones, where different water masses meet and create mixing turbulence. These thermal preferences create biological zonation patterns that shift and flow with the currents, turning the chamber into a dynamic habitat mosaic that changes continuously as different water masses pass through. The acoustic properties of these deep currents add another layer to the complex soundscape you have been experiencing throughout your journey. The flowing water creates subtle acoustic signatures that vary depending on the current's origin and chemical composition. Remember the ice songs that provide environmental information to resident organisms. The current sounds serve a similar function, allowing marine life to identify favorable conditions and navigate through the three-dimensional current landscape using acoustic cues that reveal information about water quality, nutrient content, and flow patterns. You have reached the deepest part of your exploration, where you finally understand the most remarkable secret of this underwater world. The ice shelf itself is alive in ways that transcend simple geological processes. The massive frozen ceiling above you breathes with rhythmic expansion and contraction cycles that maintain the delicate balance necessary for this entire ecosystem to exist, creating a living system where the boundary between geology and biology becomes meaningless, where ice and water and life function together as a single planetary organism that has been operating successfully for thousands of years. The breathing of the ice shelf operates on multiple timescales, rapid movements that respond to tidal forces and temperature changes occur several times each day, creating subtle pressure waves that pulse through the water like a massive heartbeat. Longer cycles that follow seasonal patterns cause more dramatic expansions and contractions that reshape the chamber architecture over periods of months, while the longest cycles respond to climate variations that occur over years or decades, creating evolutionary pressures that shape the biological communities over extended time frames. This rhythmic movement of the ice serves essential functions for the ecosystem below. The expansion and contraction cycles pump fresh water through the chamber, creating circulation patterns that distribute nutrients and oxygen while preventing stagnation that would quickly become toxic in such an isolated environment. The ice breathing also generates the pressure variations that create many of the acoustic phenomena you have been experiencing, turning the entire ice shelf into a massive instrument that plays environmental music for the benefit of the organisms living in its shadow. Glaciologists studying these breathing patterns have discovered that they are far more complex and coordinated than simple thermal expansion. The ice shelf appears to respond to biological activity in the water below, adjusting its breathing patterns to optimize conditions for the marine communities that depend on its stability. This suggests a level of feedback between the geological and biological components of the system that approaches the complexity of living organisms, where the ice serves as both habitat and active participant in ecosystem management. You can feel the breathing most clearly when you position yourself near the ice ceiling, where subtle movements create pressure changes that affect your buoyancy and the behavior of your equipment. During expansion phases, the chamber becomes slightly smaller and the pressure increases, while contraction cycles create more space and reduced pressure that allows dissolved gases to come out of solution, creating temporary clouds of bubbles that rise through the water like underwater snow falling upward toward the ice ceiling. Researchers still argue that this ice breathing might represent a previously unknown form of planetary self-regulation, where ice sheets actively participate in maintaining environmental conditions rather than simply responding passively to external climate forces. Some scientists propose that ice shelf ecosystems like this one could serve as climate control mechanisms that help stabilize regional ocean temperatures and circulation patterns, while others argue that the apparent coordination is simply the result of complex physical processes that create the illusion of intentional behavior. The indigenous peoples of polar regions have long recognized that ice formations possess what they describe as spirit or consciousness, the ability to respond to environmental conditions in ways that seem to indicate awareness and intention, rather than simple mechanical reactions to physical forces. These traditional perspectives, often dismissed by conventional science, appear remarkably consistent with modern observations of ice shelf behavior that suggests coordination and responsiveness that exceeds purely physical explanations. Remember the entire journey you have taken through this hidden world, from the bioluminescent creatures that create living constellations, to the amphipod cities suspended from the ceiling, from the bacterial gardens that transform chemicals into life, to the colonial forests that connect all the habitat zones, from the ancient water that preserves liquid history, to the surface visitors that bridge different worlds, from the deep current highways that connect this chamber to global systems. All of these components exist because the ice above maintains the precise conditions necessary for their survival through its rhythmic breathing that has continued uninterrupted for millennia. The breathing patterns also serve as the master clock that coordinates biological activities throughout the ecosystem, reproductive cycles, feeding behaviors, and migration patterns all follow rhythms that synchronize with the ice expansion and contraction cycles. This creates temporal organization within the community that ensures different species do not compete directly for limited resources, while maximizing the efficiency with which nutrients and energy flow through the various trophic levels of the food web. The most profound aspect of the ice breathing is its role in maintaining the chemical stability of the ancient water masses. The pressure cycles prevent chemical stratification from becoming too extreme, while ensuring that different water layers maintain their distinct properties over extended periods. This delicate balance allows the chamber to serve simultaneously as a preserve for historical ocean conditions and as a dynamic habitat that supports complex biological communities, bridging the gap between geological preservation and biological innovation. As you prepare to conclude your exploration of this hidden world, you realize that the ice breathing represents the fundamental life force that makes everything else possible, the slow, steady rhythm that has sustained this underwater universe through countless climate changes, seasonal cycles, and evolutionary transitions, creating one of the most remarkable and persistent ecosystems on Earth in a place where life should be impossible. Now, as your journey through this hidden world beneath the ice draws to a close, you begin your slow ascent toward the surface, carrying with you the memories of mysteries that few humans will ever witness directly. The bioluminescent creatures that surrounded you with living starlight seem to pulse more gently now, their displays becoming softer and more rhythmic, as if bidding you farewell with a final light show that acknowledges your respectful presence in their ancient domain. The sounds of the singing ice walls fade gradually as you rise through the layers of ancient water, the acoustic symphony that has played continuously for thousands of years, becoming a gentle whisper that follows you upward toward the world of sunlight and warmth that awaits above. The breathing of the ice shelf continues its eternal rhythm beneath you, the slow expansion and contraction that maintains this underwater universe operating with the same steady patience it has shown for millennia, indifferent to your departure, but somehow acknowledging that its secrets have been witnessed and appreciated by a visitor from the surface world. The bacterial gardens far below continue their chemical alchemy, transforming harsh compounds into the foundation of life, while the amphipod cities maintain their busy routines in tunnels that have been home to countless generations of tiny architects who have never seen sunlight yet have created beauty that rivals any human construction. As you near the surface, the water around you gradually warms and the pressure decreases, your body readjusting to conditions that will soon allow you to breathe the air of the surface world, while your mind struggles to process the extraordinary complexity of the ecosystem you are leaving behind. The crack in the ice that serves as your exit grows brighter above you, promising return to familiar surroundings where gravity works in predictable ways and life depends on energy from the sun rather than chemistry from the deep earth. But part of you will always remain in that underwater cathedral, swimming through ancient waters where ice sings lullabies to creatures of living light, where time moves in rhythms measured by the breathing of glaciers and the slow circulation of water that remembers the climate of ages past. Sleep now and dream of hidden worlds, where the boundaries between geology and biology dissolve into something larger and more mysterious than either science alone, where the planet itself participates in creating sanctuaries for life in the most unlikely places, breathing slowly and steadily through countless nights and days, maintaining the delicate balance that allows wonder to flourish in the darkness beneath the ice. End of script. Sweet dreams.